She was a sailing boat at the very beginning. She was quite light, about 12 tons. Now she's 35 tons because we have a lot of equipment inside. Energy Observer, at the very beginning, it was just a laboratory vessel, just to find out if the kite system were something possible for the maritime industry, then if the vertical wind turbines were a good solution. Then we tested a lot of different solar panels and batteries, and the biggest innovation was the hydrogen chain. So we take the seawater, we desalt it, we electrolyze it, we compress it, and then we have a fuel cell to get the electricity out of the hydrogen. When there is no more sun or wind or whatever, we still have this big storage of energy in form of hydrogen. We strongly believe in the mix of energies. How to keep the energy when you got too much of sun, too much wind, and you know that in the next 5 days you will have not enough. So the mix of energies is very important because it provides you some security in terms of energy sources, and then the hydrogen allows you to store it on the long term. We've got one megawatt hour stored in pure electricity in hydrogen. We have 62 kilos of hydrogen storage, and we have 100 kilowatt hours in forms of lithium batteries. So altogether, with no wind, no sun, nothing, you can sail at about 6 knots for 6 days. At the very beginning, everything was custom made. The first fuel cell was a prototype. The electrolyzer is based on an electrolyzer designed for hospitals, and we just modified it. And we had to adapt the desalination. We had to invent all the compression stages to have the best, most efficient system. But it was so expensive, so custom made, that all the communities that we met around the world, the fishermen, the passenger boats, the ship owners, all of them, they told us, okay, it's very nice, it's very interesting, but what can we do with it, So we decided for 2 years now, to just go in downsizing in terms of cost. So we use more and more out-of-the-shelf commercial, industrial components for the ocean wings, for the hydrogen. Now we use a Toyota fuel cell. We stopped, trying to get the best efficiency from every component. Now we just try to have something which runs smoothly, very high reliability, because now we need to convince the maritime communities. And that's not the same job as getting the most out of a system. When you see what has been the hydrogen activity for the last 2 years in Europe, in France it's 7 billion euros planned, in Germany it's 8 billion plans, in the US it is the same everywhere, so they are investing massively. In about 5 years, you should have more than prototypes. You should have some working cargo ships on hydrogen and electric with the hydrogen range extenders. Yeah. Now the purpose was first to showcase that it works, even in the worst conditions. And now the purpose is much wider. Now the purpose is to be able to design affordable, reliable systems and to offer them to the communities. Testing, destroying systems, components, solar panels, batteries, tanks and everything, and rebuild and modify and adapt and optimize. And it's just a big amount of experience to put all these systems in a very corrosive atmosphere. Thanks to all what we have done on this boat now, we are able to design very, very competitive and very efficient systems for many, many applications.